All right, so thank you for coming today and joining me this afternoon at this session. Today we're going to be covering primary storage for SaaS solutions. So we're going to talk a little bit about SaaS, some storage solutions. We're going to cover some partner solutions today. Just as another show of hands, how many of you guys here are APN partners today? Okay, a good amount. So let's go ahead and dive in. So I'm presuming if you're in this session, you either already have built a SaaS or thinking about building a SaaS at some point, or just interested in SaaS in general. So I'm just going to real quickly breeze by, some reasons, or some thoughts around why building SaaS. So we looked at the IDC survey that was recently done, and they looked at customer demand and preference around SaaS solutions. So the first thing they looked at was customers doing SaaS-first deployments, right? So for many years, customers have started adopting a cloud-first mentality, right? Certain customers are going cloud-first for new applications. Well, now we're seeing customers also doing a SaaS-first approach to selecting new solutions. Some customers also have, in a similar manner, company-wide solutions for exploring and migrating to SaaS. In addition, customers are also opportunistically looking at exploring SaaS. So looking at exploring SaaS when their next license renewal or renewal of an application, or they're starting to rebuild or look at a new application to start to go towards SaaS. And then altogether, there's about, if you look at those three kind of categories, about 72% of those surveyed here by IDC were considering SaaS for their solution. So that's a pretty big aspect, a large aspect of the market that building a SaaS solution is going to help to satisfy. So now that we kind of briefly looked at, some of the whys, we know it's something customers are looking for, how do you build a SaaS solution? And specifically, again, we're going to be looking at how to build storage solutions as part of your SaaS solution. So many of you have probably heard of or seen the AWS well-architected framework. It's basically a list of best practices that AWS provides to help you build, an application that's going to be great for customers. There's 5 pillars involved in the well-architected framework, and they apply to all aspects of your application, but also apply to the storage solutions that you're going to use. The first is operational excellence. Then we have security, reliability, performance efficiency, and cost optimization. So the key to building, a good storage layer SaaS application, is to be able to follow these kind of principles. So let's look at, how you kind of choose the right solution. So as you guys can imagine, there's not really a one-size-fits-all. It's really about finding balance, right? Finding the right thing that's going to meet what the needs are that you're looking for. So as we look at each of the kind of pillars, you could see that, they have different aspects in terms of storage solutions. So like reliability, you want to see if your solution is zonal, global, or regional, and we'll go over what that means in just a minute. In terms of cost optimization, you want to make sure that you're selecting a solution that's going to provide the right value. You want to make sure you have the right encryption and security as part of your solution, so you can make sure, especially a SaaS solution where you're generally going to have multi-tenancy, as part of your solutions and multiple customers' data that's going to be part of that solution. It's very important to understand how access control is handled, to understand how encryption is handled. Are you using your keys? Are you using a customer-provided keys? Can the service support those things? Performance. Are you handling performance for a single customer, or you're handling performance for thousands of customers or tens of thousands of customers. And of course, operational excellence, which is, are you able to manage, monitor, and respond efficiently to what's happening with your solution. So one of the key benefits to building a SaaS solution on AWS, and one of the key considerations you want to take in mind when building a solution in AWS, is the AWS global infrastructure, right? So AWS currently has 22 geographical regions around the world and 69 availability zones within those regions, and that's continually expanding. So as you're building your solution, you want to think about where are your customers, right? Where are they in relation to these different regions? Do I need to build redundancy across these regions? Is it redundancy just within a certain geographical area? Is, like, for instance, do you want redundancy across East Coast and West Coast of the United States, or do you want redundancy in a worldwide manner? So do you want to have your deployment in, in US West and another deployment in London? All this is possible on the AWS platform because you don't have to build, data centers in these various locations. AWS already provides that global infrastructure, and you can within minutes deploy these solutions across. And we'll look at a little bit about how to do that. Now, again, just a brief look into what an availability zone looks like. So I mentioned we have, 69 availability zones in those 22 geographical regions. So availability zones is one or more data centers that help customers to be able to build reliable solutions. So you can see there's a significant amount of network connection between those various data centers within each of those availability zones. So I'm not sure how easy it is to see there, but you can see like each of the squares there are the availability zones, and they contain one or more data centers that are interconnected and then connected up to transit centers within the region. There's some good videos online if you look at them, if you're interested in kind of deep diving into how these availability zones are set up and how some of these network connections look like. There's a lot of information that you can find out. I specifically recommend Tuesday Night Live with James Hamilton from reInvent a few years ago. He kind of dives into some of the interesting points on this, but I'm sure there's some good sessions even at this reInvent that you can check out if you're interested. So now let's dive into, I mentioned before, zonal, regional, and global services. And it's important to understand this when you're building for redundancy and for reliability. So what is the difference between these different things? So a single service, can exist either in an availability zone, which again, is one of those locations that are separated, from the others. It has one or more data centers, and it's separated for faults from the other availability zones, right? So when you talk about zonal service, generally a zonal service exists in one of those availability zones. You can deploy different aspects of the service in different availability zones, but there's not redundancy across those availability zones. If the zone becomes unavailable for whatever reason, then that service or your use of that service or that data that you're storing at that service would become unavailable. Then you go up to regional services. So as we talk about regional services, we're talking about a service that operates in multiple availability zones, right? So it operates, we consider it on the regional level. So these kind of services are generally protected against availability zone failure. So if one availability zone becomes unavailable, for some time, your data is still accessible. Then you go to the global services, and these are services that operate across multiple regions. So remember we talked about those geographical regions, 22 geographical regions that are located all around the world. So these kind of services are protected and can survive from not only an availability zone being unavailable, but an entire region being unavailable. You still have access to your data. So let's just take a look at some of these services that are, zonal versus regional versus global. And this is just to give you, some idea of what I'm talking about here. So as you look at, a couple of the core services, you see right at the beginning in the zonal service category, Amazon Elastic Block Store, otherwise known as Amazon EBS, and Amazon Elastic Compute Cloud, otherwise known as Amazon EC2. So those services, when you deploy it, so if you deploy an EC2 instance or you deploy an EBS volume, exists within an availability zone. Now you can deploy, for instance, an instance in one availability zone and another instance in another availability zone and set up your own type of replication or other things between those instances, but a single EC2 instance only exists in a single availability zone at a given time, and a single EBS volume, same thing, only exists in a single availability zone at a given time. So if that availability zone becomes unavailable, then your instance or your EBS volume is also going to be unavailable. Now you look at regional services like Amazon Simple Storage Service, and that service, same with Amazon S3 Glacier, that service is a regional service. And so you might have heard about Amazon S3 and how it's protected across 3 or more availability zones, right? So what that means is if an availability zone, and there is one exception, which is there's a storage class in Amazon S3 that's called Amazon S3 One Zone IA. That's the only storage class within Amazon S3 that's zonal. But all the other storage classes, including all the Glacier storage classes and Glacier Deep Archive, are all regional in nature. So when you store your data on Amazon S3 or Amazon S3 Glacier, it's protected against availability zone failure. So if an availability zone becomes unavailable, your data is still available to your applications. Lastly, global services, right? So we look at, the two that I mentioned here is Amazon CloudFront, as well as AWS Identity and Access Management, or IAM. So those services exist outside of just a specific region, and exist across the globe. Now, even if your service by its core nature is zonal, you can combine it with other services to make your application regionally available. So if you look at this example, you can kind of design up the stack, if you will. So this is combining more than one service, or it may just be features of a particular service, but in this case it's multiple services. And we're combining Amazon EC2, we're combining Elastic Load Balancing, and Amazon EC2 Auto Scaling. So we're building instances in our application that exist on instances across those multiple availability zones. So now the application as a whole is protected on a regional level, even though the individual services are zonal in nature, right? So this is going to be important as we start looking at the storage services. So again, same applies to walking up the stack when it comes to going from a regional service to a global service, right? And as I mentioned, it's not only just combining services, sometimes it's enabling certain features. So in this case, when we're talking about Amazon S3, remember I mentioned Amazon S3 is a regional service. Now, if we look at using a feature called cross-region replication within Amazon S3, which enables you to replicate your data from a bucket in one region to a bucket in another region, right? So now your data is actually protected from regional failure, right? So now you, in essence, created your service or your application to be global in nature. So even if you lose an entire region, your data is still accessible to your customers. So as I mentioned, really balance is what it's all about. So when you're building that storage layer, you're going to see from your customers, because remember, you're managing a SaaS solution, right? So the customers are not seeing all the internals or how it works. So when you're thinking about like requirements, the customers may be coming to you and saying, hey, I want, this to cost, less, right? I want this to be very affordable, and I want it to be very performant, right? Of course, depends on what your particular application is and what it does, on what the customer is going to ask for. But, often when I've worked with partners, and I'm a partner solution architect, so I work with partners on building their solutions on AWS. And when I work with partners, one thing that I sometimes see partners fall into is they say, well, customers aren't really asking for security, right? They're not really talking about security, or they don't really care how our operations run. So I might run through, well-architected review or architectural review with a partner, and they say, well, customers aren't really asking for those things. I'm just going to focus on making my solution cheaper because that's what customers are asking for, or making it go faster. But I'm not really getting concerned about the things on the other side of the balance. But when you think about customers, there's what they may be asking for and what they actually expect, right? So customers are not going to ask you to make sure that their data is not stolen, or that their data is protected, or their data is reliable, or your service is reliable. They're going to expect that, right? When you go to get a car, you may say, hey, I want a car with this feature and that feature and whatever, but the dealer's not going to say, well, no one really asked for wheels or asked for an engine, right? It's kind of an expectation, right? So when you're thinking about a SaaS solution and building that for customers are going to expect their data to be secure when it's on that solution. They're going to expect the solution to be reliable, and they're going to expect you to be able to operate it efficiently so that you can provide that level of reliability to the solution. So how do you find balance? Now, there are many ways on the AWS platform to find balance. AWS offers a wide variety of services, over 165 different services before we started reInvent. By the time we end reInvent, that number will probably be a lot bigger. Today I want to share some storage solutions that are provided by APN partners that can help you get a kind of jump start around this. These are solutions that we've looked at with partners in terms of building them to meet these kind of well-architected principles. So let's get started and look at the first solution. So remember I talked about combining services in order to meet those balance requirements. So one of the, two of the services we're looking at here is Amazon EC2 Instant Storage, which, if you guys aren't familiar with what instant storage is, it's basically local storage that's on the EC2 instances. So Amazon EBS exists outside the EC2 instances. You create volumes and you can attach them to an EC2 instance, but Amazon EC2 Instant Storage exists on the individual instances. So it could be either hard drive or SSD based. In this case, with Wekalo, they're using the SSD based storage that's connected via NVMe. So it provides a very high speed solution. But in order to balance that out, they also use Amazon S3 to provide both cost efficiency as well as durability for those solutions. So with this solution specifically, it's designed very much around performance. It's a scale-out architecture, so it's basically you have various nodes that you can add. You can start with 6 nodes, but it's been tested on AWS to go up to 240 nodes. And you get linear performance at scale. So this is important because you can, if you're building a SaaS solution, you want to be able to judge how many users can use that solution when you're deploying it, right? So if you have linear performance, you could say, okay, if this level of performance meets, 100 users, then if I times that by 10, if I have 10 times as many nodes, well, then I'm going to be able to handle 1,000 users on my platform, right? So having that linear performance really helps. And, to give you an idea of the performance that they're able to get, they recently did a benchmark test. That's a industry recognized benchmark test, which is the IO 500 test. I don't know if you guys have ever heard of it. It's big in the HPC community, where they test different file systems for both throughput and metadata performance. This was at Supercomputing 19, which is a big high performance computing trade show. And Weka won the #1 place on AWS. A lot of the other vendors that were participating in that used very huge on-premises clusters. This was I believe the only or one of the only participants that ran on AWS, and they won the #1 spot for performance. And that was actually using the new i3EN instances that support up to 100 gigabytes of network throughput per instance. So the key to this is also you can actually size it to match both performance and capacity. So you can have larger amounts of capacity on S3, or larger amounts of, if you need more performance, you can scale up the nodes to have more performance tier. So you can really independently scale the performance and the capacity. So let's take a quick look at what the architecture looks like. It's a fairly simple architecture. Again, they run on the instance types that provide instance storage. Not every instance type has instance storage. So you can see here they're running on the i3 instance type, and you basically create a cluster of again 6 nodes up to as many nodes as you need, but there's been tested up to 240 nodes on AWS. You can also build multiple clusters as your needs for your SaaS solution exist, and then you would have your clients that can access the Weka cluster. Some of the key features that are part of this that can help with your solution is they offer snapshotting to S3. What that means is essentially you can take a point in time of the cluster, send that data with all the associated metadata down to Amazon S3, and then you can even shut down the cluster and be able to bring it back up to that point in time. So let's say you have a SaaS solution that only has activity at certain times of the day, for instance, right? You can potentially have that compute only running, at that time, snapshot to S3, and bring that back up as needed. You can also use that feature to snapshot your data S3, then use cross-region replication, and send that data to an S3 bucket that exists in another region, and then be able to mount that volume on a Weka cluster that you spin up, whether it's just in time for DR, to do processing in another region, or to make that data available somewhere else. So without having to build all that functionality yourself, into there, figuring out how to, spread the data across multiple nodes, how to get that performance, you're able to do that right in here. And they also offer a parallel client for your Linux instances. So what this means is you can load a client on your instances that gives you a full POSIX file system, and it handles the parallel connections to all the different nodes, which enables you to get very high per node throughput. So if you're doing something where you're using like GPU nodes, for instance, and you need to get a high single stream performance, this enables you to get parallel performance by using all the nodes in the cluster to a single client. They also support SMB and NFS, as well as I mentioned, tiering down to S3. So that's again a good solution if you need high performance, if you need SMB, NFS, you need those file protocols. But what if you need block storage, right? Sometimes you need to have block storage, and you need some of those features. Pure Cloud Block Store is a fairly recent solution. It was made GA back in September. This uses a scale-up architecture as opposed to, the last solution that we looked at, which was Weka uses a scale-out architecture, which means that you add a bunch of nodes. In this, it's a kind of more of a scale-up architecture where you have, 2 nodes that are the primary controllers, similar to a on-premises storage array. If you guys are familiar with on-premises, Pure makes storage arrays on premises and data centers. Similar kind of concept here, right, where they have two nodes that are the controller nodes in a scale-up architecture. So you basically, if you want more performance, you make those nodes to higher instance types. So they combine, again, instance storage, Amazon S3, and in this case, they also use Amazon DynamoDB to handle some of the metadata, right? You can deploy this solution in a multi-AZ, high availability configuration. It provides, native block storage. So if it uses iSCSI, and basically you can connect it to your instances via iSCSI for your data volumes. And it supports synchronous replication across availability zones. So let's take a quick look at that architecture. So again, as I mentioned, you have your two controllers, and then you have what's called like a data group, or they call it a disk shelf, which is essentially a series of those I3 instances that provide that instance storage. And what they do is they create those into kind of virtual disks that are associated to those controllers. Then they send that data down to Amazon S3. For durability purposes, but all the kind of reading and the read cache all happens through those really, really fast instance storage volumes, so you're able to get very, very high performance. They have a lot of enterprise features that you might be used to or aware of, like instant snapshots, always on encryption, thin provisioning, deduplication, which again, for a SaaS solution, if you're having, multiple customers running on there, you may have, similar data sets, right? You may have, a data set that you provide on your instances that, maybe is a golden copy and the same across, 10, 20, 50 instances, right? So if you're deploying in this scenario, if you have 1 terabyte volume that is handed out to 20 instances, you don't have to use 20 terabytes of actual storage, right? Because with the deduplication, that's functionally becomes 1 terabyte or close to that is going to manage just the changes, right? So you're able to do that, and you're able to use cloning and other features like that to create additional environments. So what does it kind of look like with the with the replication across availability zones? So you could see again we have the full array that exists in a single availability zone, and then they have a feature called active cluster. And so what this does is it handles actual synchronous replication between those two arrays that exist in different availability zones. So that means that you essentially are turning the service into a regional service, right? Because now if you have customers on your SaaS solution that that uses block store or uses cloud block store, here even if an availability zone goes away, you're still protected from that data without having to, again, build your own replication or your own functionality, right? You don't have to figure out how to do deduplication, how to, how to make that synchronous replication happen. Now, in the same kind of setup, you can also set it up for asynchronous replication across availability zones, right? So you can actually, I'm sorry, not across availability zones, but across regions rather. So again, if you wanted to take this same service and you wanted to make it, regional and or global in nature, you could take that same service and just enable asynchronous replication to another region, and then you have availability there. They also have a feature if you don't want to necessarily or need to have another entire array there. They have a feature called Cloud Snap where you can send just a copy of snapshots to Amazon S3, and then you can have them available in another region, and then you can bring those on a pure array just in time, right? So if you were using it for like disaster recovery, for example, and you didn't need as fast of a RTO, you could just send that data down to S3 with the snapshots and all the related metadata, and then be able to spin up a pure cloud block store array just when that DR event should happen, and then be able to return the data. So it's important to understand, for your SaaS solution, what is the recoverability requirements by the customer, what's the customer expecting. So if they're expecting 100% uptime from you guys, or you're providing a very high SLA, you may want to have an array in multiple regions up and running all the time. If based on the nature of your application, if you're doing something that's more in the background, and you're not necessarily needing to be up all the time, but you want to be able to recover in the case of a global disaster, you may use something like a Cloud Snap feature that will send that to S3, and then you can recover it and not have that cost of the running EC2 all the time. Now, another popular deployment methodology in SaaS is kind of more of a pod architecture, right? Where you may have a users or a group of users that are separated into, a kind of pod, so that you're having these smaller kind of footprint environments, and each time you deploy the next 10 users, the next 100 users, whatever it is, you deploy a new pod, right, of your application. So it's kind of a new instantiation of your SaaS application under the covers, right? One solution that works nicely with kind of pod architecture, because the requirements are kind of a bit smaller in terms of running it versus something like a Cloud Block Store, is NetApp Cloud Volumes ONTAP, or otherwise known as CVO. So this, again, similar to Cloud Block Store, is a scale-up architecture. So again, it's using 2 nodes, and it uses Amazon EBS onto the covers, as well as Amazon S3. It can, in certain cases, use EC2 Instance Store as well as part of a caching mechanism. But most deployment models, this is using Amazon EBS for the primary storage layer. So this can be deployed in a single cluster or a single pod, as in multi-AZ configuration. So you have the 2 nodes that are your controller nodes. You can have them in different availability zones. So the same cluster is by nature in different availability zones with just 2 single nodes. So you don't have to have a whole larger implementation. It provides the same native block storage. So it provides through iSCSI. It can also provide file storage, so it provides SMB and NFS, so it combines both block and file storage solutions together. It also has its own native replication that's part of the solution. So you can replicate, for those familiar with NetApp on-premises, you can replicate between your NetApp arrays on-premises. You can replicate between your NetApp arrays that exist in different availability zones. You can replicate between your NetApp arrays that exist in different regions, right? So you get all of those options. You can deploy it as a zonal service, which is generally not recommended, but you can deploy it as a regional service, to have multiple availability zone configuration, or you can deploy it globally and have arrays that exist in different regions that you're replicating to. And this starts, as low as 2 terabytes for the minimal configuration. So again, if you're building a smaller configuration, you can have this as small as 2 terabytes, and it goes all the way up to 368 terabytes per cluster, right? So you could build your pod architecture to kind of fit within those parameters. So if you have, a kind of smaller solution, or smaller in terms of the amount of data that needs to be stored in a particular pod, you can make these really, really small, or you can pump these up, to have, petabytes of data if you deploy multiple of these configurations. So it's 368 terabytes per cluster, which is essentially per 2 of those nodes, and you can deploy as many as you want within your SaaS solution. So let's take a quick look at that architecture. So as you can see here, the 2 nodes on your left and your right there are within 2 different availability zones. You can run them on M5 instances, and again you can see the EBS volumes that are attached to each of those nodes. So what they do in the multi-availability zone configuration is they actually have internal synchronous replication that happens between the two nodes there. So you get actual copy your data on EBS on the first node, and then copy your data on EBS on the second node. Then there's a mediator that kind of monitors, that's in a separate availability zone that kind of monitors the two nodes and can handle failover, right? So if you have an event where one availability zone went away, or just even one, the node in that availability zone went away or was unavailable for whatever reason, the mediator would be able to detect that and fail over to the other node. And it does this kind of with routing in terms of the IP addresses. There's a private IP that gets assigned that could float between each of the nodes. So when the mediator detects that a node is unavailable, it's able to switch that routing in the routing table to point that IP to the other node. So your clients automatically will send the traffic to that other node. And then there's a cloud manager that essentially lets you manage that whole environment. It provides like a graphical interface so you can manage not only one cluster, but multiple clusters, right, throughout your environment. So you really only need one cloud manager, and you can have 50 clusters that are part of that cloud manager. So again, this gives you things like instant snapshots. It gives you clones. It gives you multi-protocol support, as I mentioned, SMB, NFS, but you can also even have both of them combined on singular volume, as well as multi-availability zone failover. So now what if you want to take it kind of a step further? What if you want to say, hey, that's great, I can fail over, I can fail over between availability zones on my data layer, but maybe you have an application that also needs to fail over with your data, right? So there's a solution called Veritas InfoScale. And so InfoScale provides not only shared storage that handles failure on the storage layer, but it actually allows you to build a cluster that handles failover of an application as well. So you can build an application on this, like maybe you have various different, mission critical applications as part of your SaaS solution that you want to be able to fail over either to a different availability zone, to a different region. All you have to do is deploy InfoScale on those systems. It works in kind of like a hyper-converged way, so you can run your application on the same nodes that you have the InfoScale application running, and you have it as part of your storage cluster. It's able to use EBS volumes as well as instance storage for caching, and Amazon S3 to provide additional storage and to provide durability. So you can scale the compute and the storage independently. This is kind of a scale-out architecture, again, similar to what we looked at, with Weka, right, where it's not a scale-up. You can essentially add multiple nodes to a cluster. So this can, scale to large amounts of nodes in an individual cluster. Depending on your SaaS solution, again, you may need to scale individual clusters more, or you may need to build more clusters, right? It's kind of up to you. It's flexible in that sense, right? So if you need to separate out customers in different ways or provide different security boundaries, right, you can do that within a cluster or within a kind of group of clusters. And then you can kind of, again, it's very flexible in terms of, if you need more performance, you need more capacity, you can kind of adjust the clusters to kind of meet those different needs. And it can handle the actual failover, as I mentioned, of the application. So it has, ways where you can tell it like how your application needs to fail over, whether that's handling, IP address failovers, or, or making, changes in running certain processes, or stopping and starting certain processes as part of a failover activity for your application. So they've been very big in applications like SAP, for example. SAP is run on InfoScale with many enterprise customers, where they kind of program it to, be able to fail over, SAP from one location to another. So as I mentioned, you can kind of have, global disaster recovery or global presence with this. So you can have an InfoScale cluster that's running, in one region, size to whatever you need for that particular region. Then you can have a InfoScale cluster running in another region, and you can have InfoScale handle that replication for you, right? So you can build a very customized solution in terms of performance, in terms of capacity, for each of your kind of regions, and then determine where you want those to have your disaster recovery, whether that's from US East to US West, or even across the globe. So you can have it no matter what the kind of distance is. Now, depending on how you build out your SaaS solution, you might have multiple VPCs as part of your SaaS solution, or multiple accounts even as part of your SaaS solution. And now storage, you may want to have in a core account, or you may want to make that available to multiple resource accounts, right? So you may have some of your compute running in one account, and then your storage running in that core account. One of the ways that you can kind of address that type of scenario is by using AWS Transit Gateway. Now, Transit Gateway is a service that was released a while ago by at AWS, and it's starting to be used by some of these storage partners. NetApp, for instance, has prescriptive guidance around how to use Transit Gateway as part of your solution. So in terms of Transit Gateway, what it'll do is it'll allow that routing from your storage solutions, whether you're using private IPs, to other AWS accounts, or even to various other regions or other locations where you're going to have those accounts. You can tie them all into a Transit Gateway service, and you can have it be able to handle the routing between these various accounts and to get to your storage solution. So you may have your clients or your application running in one VPC or in one account, and your storage running in another. In Transit Gateway, you can configure it to route that traffic to your. Now, there's another solution, kind of the last solution that I'm going to be talking about today, is a solution that provides zero RPO at any distance, right? And in case everyone's not familiar in the room, RPO is recovery point objective. So this is, the point in time in which you can recover your data, right? So kind of a zero RPO means you can kind of recover your data immediately. You don't have any data loss within a given solution, right? Which, as you think of like as a SaaS solution, that's kind of important, right? Because it's not just your data, it's your customer's data, right? That you're providing. So it's hard to go to every customer and say, okay, what's your RPO, what's your RPO, what's your RPO, right? So having an RPO of zero means essentially you're not going to lose data, right? So that's kind of really important and critical in a SaaS solution. So this is kind of a new solution. It's actually pre-GA, so it's scheduled to be generally available by the end of the year, but it's not currently generally available. But it combines, Amazon EBS and EC2, and it provides, zero RPO, as I mentioned, across regions, regardless of the distance, right? So you're able to access this as block storage provided by iSCSI, and there's kind of a one-to-one mapping between what they have as a virtual volume and an actual EBS volume. Why this is important is you can essentially access that EBS volume even outside of this solution. So if you're using this solution, to provide your data, to use your data and provide that zero RPO. If for whatever reason, you stop using the solution, or, you want to go around the solution, you can actually take those EBS volumes and you can mount them directly to your EC2 instances. Now, you won't get the zero RPO once you do that, right? That, replication will stop, but you'll still have access to those volumes, regardless of the solution or not. So how this does this, we'll take a look at. It essentially, writes, synchronously to a second availability zone, and then writes, asynchronously to the other locations. So let's take a quick look at what this looks like. So this is, essentially the setup where you have your app server in the, in the first availability zone, and then you have, edge devices is what they call them that run on EC2, and they mount to an EBS volume, right? They then provide you an iSCSI volume to your app server, and when you write to a, to an edge server, it's essentially going to, as part of that write, do a synchronous write to a service that exists in the Replix SaaS account, right? So they're going to, when you configure this volume for Replix, it's going to deploy, a node or have a node available in a separate availability zone than where you're running, the EC2 instance. Because remember, I mentioned that EC2 and EBS exists within a single, availability zone. So when you deploy this, your edge server and your app server and your EBS volume are going to be in a specific availability zone. Then Replix is going to have a node that exists in a separate availability zone. So when you do that initial write, it's going to write to that that node that exists in that one availability zone and to a Replix node within their SaaS solution that exists in another availability zone. So immediately, as soon as that write is committed, you're protected across availability zone failure immediately. Now that same write at that time so you're going to get the response back to the client. That's going to be the synchronous part. So once you get that response back that the write has happened, you're protected against that instance failing, right? Because you have the data on that second node. Now, as soon as that happens, they're going to start a asynchronous, replication of that data or push to that data to a node that exists within their solution or through their Replix network as part of their SaaS solution to other nodes that are closer to where the target node is, right? And this is how they're able to actually do it across any kind of distance, right? Because what they're doing is they're first protecting that data, locally against availability zone failure, and then they're starting to move that data to closer and closer nodes till you get towards your end node, wherever that may be. So if you have your one node in US East and your other node, all the way in Tokyo or Singapore, right? That's a long distance, right? Or even, something like Sydney where it might be, 200 milliseconds away, right? Normally replication is going to take a while to happen to that. So if you have a one-to-one relationship, it's difficult to get that level of replication. So they're going to have it go through their network within their SaaS solution, and it's going to then ultimately write to another edge node that exists in that second region. So it's going to be available within that second region. So even if your entire application goes down or the availability zone that your application is goes down, once that write happens, it's available within the Replix network. And that point in time is going to be available to you at that final location. There may be a replication lag, right, because it's only the speed of light that can happen, but that point in time is going to be there. You're not going to have lost data, right? You may have a delay till you can bring up that data in the second location, which you can see on their dashboard what the replication lag is between those locations, but you're not going to have lost data. So it's going to ultimately get written to that second location. So just going to wrap up with a quick summary and a few next steps. I'm also going to be available after the session for questions. I've left a few minutes here at the end so you can come up and ask questions. We don't have a mic to go around, but we just come up and ask questions after the session. So quick summary. You want to find the right balance with your storage solution, right? That's why I mentioned right at the end, that's the theme throughout there. You want to find the balance, right? It's not just about, one storage solution is going to solve all your problems, right? You want to find the right storage solution that's going to provide the right balance depending on what your SaaS application is, right? That's something you want to kind of look at, and you want to work with your SA or PSA to kind of help you with that. Always use the well-architected framework as your kind of guiding principles when picking a solution and through your app entirely, right? Always make sure you're kind of following that principle. use the kind of right storage solution depending on the type of availability that you need. If you need regional availability, if you need global availability, make sure that you can use that architecture. We kind of looked at a few different architectures that can either be regional or global in nature. So when you're building your SaaS solution, you don't want your SaaS solution in general to be just zonal in nature, right? You don't want to be able to have your SaaS solution go down if you lose an availability zone, right? You want to build for failure. Building a global or a regional service gives you much better confidence to your customers to provide them an SLA or other things that they may need as part of your SaaS solution, right? And lastly, you want to provide a solution that's going to handle scale, performance, cost. The access method you need. We talked about block. We talked about file protocols like SMB, like NFS, and availability that matches your design, right? So again, it comes down to the application. Not every application is going to need to be able to withstand global failure, maybe, or not every applications need to be 100% up. It really comes down to what matches your particular SaaS application's needs. A lot of these principles are the same across different applications, but it's really for you to kind of dive deep. And I just wanted to kind of give you, an overview of some of those ways and some of those methodologies to do it. But you really got to look at your particular application to understand what is really needed for that application. So on that front, AWS has something called the SaaS Factory. If you guys haven't heard of it, talk to your PDMs, your account managers, your SAs about it. It's a great way to help your SaaS solution, help make sure you're building your SaaS solution on all layers and all aspects, the right way or the best thing that's going to meet your business objectives. So I definitely highly recommend you guys check out the SaaS Factory. We also have the partners that we mentioned today, are right there on the slide. If you guys want to take a look at those or take a deeper dive into any of those partners, your SA or account manager should be able to kind of help you get in touch with those partners if that's something you're looking to do. We also have a storage competency partner page that you can go and check out, and you can see other storage partners that have achieved our competency. And what competency is, if you guys aren't familiar with it, it's something where we look at kind of the partners that have successfully deployed solutions based on not only our well-architected principles, but also have proven success with customers, right? So these are kind of the, the highest standards that we look at in terms of partners. So check out the storage competency page, as well as check out the AWS Marketplace. So there's a storage category within the AWS Marketplace where you can go and you can get different partner solutions that can be deployed to your account or deployed as SaaS. It's a great way to be able to test out these various solutions. So that's a great thing about deploying things on AWS, right? Is you can generally try them out, right? You only generally get charged for what you're using. So you can go and deploy these solutions, try them out, see if it actually meets the needs for your particular SaaS application. With that, I want to thank everyone for coming, and please, remember to complete your survey for the session. We always appreciate your feedback. Thank you very much.